Good morning, folks. If you could keep filing in and take your seats, that's fine. If we could switch over to my laptop, fingers crossed. Hooray. Okay, welcome to my Abusing C# session. Do not take any of the code here, with one possible exception, as code that you should ever use in production. The whole point is to find code that is funny and looks potentially useful, abuses C# features, but is fundamentally kind of too horrible to let live anywhere near production code. I almost certainly won't be able to show you all the code that I've got, so you can find it all on GitHub under jskeet/demo code, and within that, it's in the abusing C# /code directory. Okay, I'm going to sit down for the whole session because it's just easier. Let me just switch over to Visual Studio. No, that's not what I meant. Right, if I have something, any code up, can everyone see that code and read it, reasonably comfortably? Because if you can't read the code, this session will be completely useless to you. Okay, is it showing on the monitors, the repeaters? Okay, good. Right, I'm getting a flick. I'm not sure whether it's sort of from the back. If things get uncomfortable, then someone go and shout at the AV guys at the back and we'll see what we can do. So as I say, the point is to have some fun. A lot of this code I wrote back when C# 5 was sort of new, so there's a lot with fun with awaiters, with some horrible abuse of async, which I probably won't go into today, because we kind of moved on since then. But I'd like to start with something that is about async, and it's about sort of type transposition. So imagine we have a web service, and ignore the implementations here, just think about what the interface looks like. I haven't bothered actually creating an interface. So we can ask, and normally we would pass in some identifier for a person or something. We can ask for their weight, their birthday, and their name. And those are three separate asynchronous operations. Fine. But we want to display the user's details on a screen somewhere, and we want all of them. So we'll want something to get all the details for a person. Now, with anonymous types, we can easily represent a person without bothering to create our own type for it. We can just have something like this. So we can have a weight, a name, and a birthday, and those are nice properties. And sure, we need to return task of object, and because the anonymous type has the named properties, and because it overrides the string in a nice way, if we run this code, we would expect this to run all three tasks in parallel, and then return an anonymous type instance and display the result. So let's just show that working. So step 1, okay. So far this should not be impressive or surprising. Agreed? Okay. So the thing is, this is kind of annoying. We can't do, you might be tempted to try to inline this as await that, await this, and await that, and sort of just, we can use C# 6 syntax, which actually I'll probably amend some of the code later on to do that. Yeah. Okay, so that looks more pleasant. Do we all agree? But the trouble is, that's no longer going to operate the same way. Can anyone see why? It's going to wait for the first one to finish, then it will start doing the second one, then it will start doing the third one, after waiting for each one. So we've lost the parallelism. It's annoying. And it's annoying to have to say, I'm awaiting all these three things, when I just want to wait for everything to be done. So let me just undo everything. Okay. So that's fine, but we would like to be able to create something that represents, I've got 3 tasks, and I want to wait for them each to finish, and then I want to get the result as 3 things. So let's start off with tuple. We can ignore the last line here for the minute. We can call tuple.create, and then give it 3 tasks. So that's creating a tuple of task of double, task of string, task of date time. Right? We appear to be awaiting that tuple. Well, we're awaiting the results of calling transpose. This is a new method. Let me show you what it does. So this is sort of hard-coded for task of tuple T1, T2, T3, or to return one of those. So we give it a tuple with 3 tasks of potentially different types. It will await all those tasks and then just call tuple.create on the result. So we can do the nice thing of create the tuple and transpose. I'm calling it transpose because it's sort of transposing the tupleness and the taskness, if you see what I mean. So instead of tuple of task, 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 we've got task of tuple of value, value, value. See what it's doing? It's important that you understand this step because it gets hairier later on. And if there's any of this code throughout the whole talk that you don't understand, by the way, that's absolutely fine. All you're losing is a little bit of enjoyment in the next hour. You are not losing anything that's going to affect your coding life later on. Please. So going back to step 2, let's run this. And we'll see that there's a problem. So we've still got 50, Fred, and a birthday, but we've lost the fact that they are name, weight, and birthday. I haven't yet written a version of this that uses the C#7 tuple syntax. But if I use the result of this, so if I just do that. If I have tuple dot, I have item 1, item 2, item 3. And that's no good. We don't want item 2, item 3. We want birthday, weight, and name. Okay. We'll come back to the names part. Wouldn't it be nice if I could just create this, create the tuple, and the fact that I have a tuple of tasks, why do I need to call that transpose method? I just want to await the tuple. And the good thing is, I can do exactly that. So with, it's in tuple extensions. If you haven't seen much to do with the awaiter pattern, you can await things other than tasks. You can await anything that has a getAwaiter method that returns something that looks kind of awaitable. And something that is awaitable has getResult and onCompleted and unsafe onCompleted, which is confusing in terms of what it needs to do. That's not required, but is required for implementing iCritical notify completion. There are lots of hairy details there. The main thing is something of this sort of nature, and this is a struct that I have included. In fact, no, this is the system.runtime.compiler services task awaiter, but I could have created my own awaiter class that was very similar. In this case, I can create a genuine task awaiter very easily, but the fact that I have the getAwaiter method, the C# compiler will pattern match and say, that means you can await it. And it's expecting to return an awaiter. All I'm going to do is call the transpose method that we've already used, and that returns us a task, and we can then call the getAwaiter method on that. So this is very similar to if you're implementing IEnumerable of t in some code, and you're doing it by composing a list of t. then when you implement IEnumerable of t.getEnumerator, you just return the result of calling getEnumerator on the list of t. Okay, so it's exactly like that. I'm just delegating the getAwaiter stuff. I don't need to implement the awaiter pattern itself. This getAwaiter is all that's required for the awaitable pattern. Okay, so this should work in exactly the same way, and we're just awaiting the tuple. This is good news. And we get the same result. Goodness. So step 4 is to try to get back to the goodness of anonymous types. And this is where it gets a little bit crazy. So, here we have something that looks very similar to the thing that didn't work before, that was going to do one thing and then another repeatedly. And then I'm saying transpose anonymous. What would you expect, or how do you think I could declare transpose anonymous to be useful? I'm calling it on an anonymous type, and I want to return an anonymous type. When do anonymous types get created? It's the compiler, okay? The compiler, when it sees this, is generating a type. Now that sounds like it's going to cause problems, because if it's generated a type with a task of double, a task of string, and a task of date time, that's not going to be useful to us, because we want a type that has, we want the same kind of type that was used here, with just a double, a string, and a date time. This is where we use an implementation detail. So the compiler, when it sees either of these types, doesn't create an anonymous type, an internal sort of strangely named type that has a date time property and a double property and a string property. Instead, it creates a generic type. So this type here, this anonymous type initialization, actually uses the same underlying type that the compiler generates as this one. It just uses different type arguments. Let's have a little look. Admittedly, I've now got to find the relevant code. Projects, demo code, abusing C# code, bin. Wrapping async, bin debug. Okay, so if we look at wrapping async, we'll see there is this anonymous type with birthday, name, and weight properties, but it's generic. So it has these very, very strangely named type parameters. Apologies, this is very small, but I can't be bothered to bump up the font when I'm going to be gone from here in a couple of seconds. So when the compiler instantiates it here, it's using type arguments of double, string, date, time. When it does it, that was in step 1, that's using double, string, date, time. And in step 4, this is initializing it with task of double, task of string, task of date, time. We can use that in our transpose anonymous, T2, T3, and then we're going to sort of transpose each of those task types. So we had a non-task int, task string, or in our case with 3 things, and we're going to initialize, create a new constructed closed type with the sort of concrete underlying types of those tasks. So that's going to be this will be the type of the result. We're then going to fetch the constructors, or the single constructor from our anonymous type, in order to extract the properties, because we don't know what these properties are called. We need to rely on the fact that they are, we can't rely on the order in which reflection gives us back the properties. If we call get properties, who knows what order it will give things back in? But if we call get constructor and find the constructor parameters, they will be in the order that they're declared in the source code. So we now have a series of tasks, with those properties. So I'm going to get a property corresponding to each constructor parameter. extract the value from the object we were given, cast it to task. We can't cast it to a task of t because we don't know at compile time what this t is, but we assume that it's of the right type, and we're going to get an array. So just to step back to our code, we've now got an array of okay, that's what our array has in the transposing code. So after we've got our array, we need to wait for them all to finish. Well, we're not actually waiting here for everything to finish. We're just saying we're going to have a task that finishes when all of those tasks are finished. So this is the difference between task.waitAll and task.whenAll. WaitAll is a synchronous method that only finishes when all the tasks have completed. Task.whenAll is asynchronous. It returns you a task that will complete when all the tasks have completed. I'm seeing nodding, this is good. Please keep nodding when it makes sense. If it doesn't make sense, go, ah, and I'll try to sort of go back over things. You can be my canary, as it were. So, we're going to add a continuation to this whenAll task. So adding a continuation basically says, when that's finished, run this code. And if any of those tasks have faulted, have thrown an exception, then we want to set our overall result to be an exception. We want to throw an exception when we're awaited. But let's assume that it's good. So by now we know that all our little subtasks have completed successfully, so we can get their results by casting each of those tasks. Remember that tasks here is an array of type task, not task of t. So we'll just use dynamic typing to get the result. So now this args has the actual weight, name, and birthday. And now it's easy. We can just call the constructor of the type that we have constructed earlier on, our anon double name date time. And we're using a task completion source here. So I like to describe async things as a bit like a cardboard box. So a promise, a task of t, is like a cardboard box that says on the front, when the green light goes bing, or comes on, then there will be a cat inside this box, and you can open the box. Great. A task completion source of t is like a cardboard box with a hole in the back, so that when we want to, we can put the cat in the box, and then say, yep, it's there now, that's fine. And the user-facing side of it just gets a task, and we can provide the result or the exception or whatever it is at the right time. So here we're putting the actual value inside the box, at which point our awaiting client will go, aha, you've given me the result, that's great. Okay, so now all we need to do is return the cardboard box, as it were, that task completion source represents, and it'll work, I hope. So we have to return task of dynamic, because we can't say anything else. But the good news is, we're not actually doing anything, we're just printing results here. But the proof of the pudding, as it were, is that here we get the right names out. We get weight, we get name, we get birthday. And we could even use them, it's just dynamic stuff. So instead of that, we could do my birthday, let's do C#6isms. And sure, we don't get compile time checking of that, but it does work fine. It has the right properties. So that's kind of cool. It's a shame that we can't express in the type system what the result would be, but it's cool nonetheless. Thank you very much. And now we can do the same trick for this task of dynamic that we did with the tuple and say, do you know what? I just want to await this, and let's put it into nicer C# syntax. Now we need the await here in order to do the transposition. An alternative would just be to do the dot transpose anonymous. They basically do exactly the same thing and get rid of the async. So that's like the previous version, and this is the new one. So basically that's taking the implementation detail and abusing it so that we have actually an underlying strongly typed model that's gone from a set of tasks to a set of results of the same type in objects that have well-known statically typed properties. They're just statically typed properties that we can't express statically because of the magic of the compiler. Okay, that's my first example. Let's kill all of that stuff. So this is a nice simple program I thought I'd show you. What do you think this code is going to do? I'm quite surprised. You're a bunch of good C# developers, and you can't tell me that this is clearly going to iterate 5 times, because I've said it's going to keep going until the limit of 5. And it's going to print x, and then the current value of x is, and it'll print x again. So this is just a simple for loop. And indeed, when we run this, it says 0, and then the current value of x is 0, 1, and the current value of x is 1. So in some ways, I'm not sure why I'm even bothering to show this. It's entirely obvious code. Any ideas how it's actually working with the 0 and the 0 as a name and the 5 as a limit as text? So var is a class. Well done. Did you spot the difference in color? Yeah. Now it's slightly ugly because I've declared var as a class inside assembly info, just so that there isn't any extra code to show. But the way the rest of the code works is kind of fun as well. So let's have a look at each line of the original code and see how it's working. So var limit equals 10. That's only going to work if there's an implicit conversion from int to var. And indeed, there is. And we can only go for a certain number of numbers, the ones that I've put in here. But we can construct a var via an implicit conversion from int. Great. Second line, there's an implicit conversion from string as well. Who'd have thought? And that just finds the index of whatever text you've given. It wouldn't work if I gave it Polish numbers, I'm afraid. I can do this because I've overloaded the less than operator in a perfectly obvious way. It's nice and simple. In fact, sorry, no, I haven't even done that. Instead, I've got an implicit conversion to int. So this is using the regular int operator, but converting both sides of it to both sides from var to int and var to int, then do the comparison. So that's fine. The difference here, do you remember this showed 0 and then ZERO? Can anyone think of the difference between these two overloads of console.writeLine that I'm using? Well, it turns out there are lots of overloads for writeLine for a single parameter. It can take string, int, object, long, loads of things. Well, if you've got an implicit conversion to int, then that's what will be used. And sure enough, there is the implicit conversion to int. Whereas this overload is only using object. So it's not going to do any implicit conversions. Instead, it will pass the var object to console.writeLine that will then format it by calling toString. And our toString returns the text. So within those 6 lines or whatever it is, 7 lines, I think virtually every line has an implicit conversion going on. But it is only implicit conversions and overriding of toString. Let's look at something slightly similar. 2 little programs. 1, 2. Let's run them both and see what happens. So, demo 1 prints 3, and demo 2 prints 10. Okay, that's slightly strange, because they're basically the same code. And this one's got a using directive for system.link, but there's no link in here. But the color is different again. You're picking up on the coloring. So, if I try to go to definition here, I can't navigate to that symbol. Let's have a look at what mystery.getValue returns. So it returns a system.link.dynamic, which is a class that we've declared in our own namespace of system.link. But one interesting thing is, despite returning something called dynamic, the implementation is to return something called static. So, far be it from me to say that I named this confusingly. So the static type is dynamic, but the dynamic type is static. So in demo 1 is using the static type of getValue, which is dynamic. So it's calling the count method. But it's actually calling the count method from link, and it can do that because dynamic implements IEnumerable of int. So it's ending up iterating over, let me show the details again, it will iterate over this and count the number of items returned. In demo 2, we don't have dynamic, the type. We have dynamic, the C# contextual keyword. So when we call count here, if you remember, dynamic typing doesn't like extension methods, like link, but fortunately, obviously it's not checked at compile time anyway, but fortunately, the static type, which if you remember is the dynamic type of the return value of getValue, whose static type is dynamic, fortunately, it has an extension method itself, a normal method itself, called count. So that's what happens when you end up calling it either on a type which is known statically to be static, or using dynamic typing. Most of the rest of this talk does not use dynamic typing, I'm pleased to say. And there's very little else that relies on the color of keywords, I think. Okay, well, so we've touched on link a little bit. But there's something about link that bothers me. It's just too verbose. It's really long-winded. All those select and where and things. It just, my code ends up being whole, 5 lines long and there are 20 characters per line. It's far too much. I want to have a much shorter kind of syntax. Something more like this. So I decided to invent linked operators. I think I came up with the idea because, the OR symbol here we sometimes call pipe, and link's all about pipelines, so it feels like really there should be something to operate here. So, linked operators, you call evil to convert any IEnumerable into the linked operators where is it called? Operator enumerable. So, funky is just an list of an array of strings. This gets us back our operator enumerable, and in fact this does use dynamic typing, so it's not an operator enumerable of string. But we're going to take away world, and we're going to add today. So at the end of this line in our pipeline, this is a regular link pipeline. So this is going to be, hello, how are you today? And this is clearly, the AND operator is clearly about filtering things. It's kind of checking that things are true. So we're going to just check that the length of each word is 5. So thinking about our pipeline, we'll end up with hello today. And then the OR operator, it's extending the pipeline, so this is clearly selection. This is the map part. So this is reduce map instead of map reduce. So that's fine. We end up with hello today in shouty capitals, and we're just going to multiply that by 3. So that's clearly going to be hello today, hello today, hello today. If I remember rightly. And let's work out the second part, the second output, and then we'll check that I've remembered rightly. So if we've got foo, bar, and baz, XORed with quux and bar, that should presumably be foo, baz, and quux, because bar is in there twice. Yeah, that's what XOR does. So let's just check that that works. Basic demo, yep, hello today, hello today, hello today, foo, baz, quux. So I sort of came up with these and then thought, that's fine, but there are quite a lot of operators that you can implement. So I've overloaded every single operator that you can in C# for operator enumerable. Let's look at a couple of examples. So cross multiply, we've seen what happens when you multiply an operator enumerable by a number. You get that sequence 3 times. What happens if you multiply 2 sequences together? It's called cross multiply, so it sort of feels like this is like select many. It's like from value in ABC from other value in 1, 2, 3. So let's see, we get tuples. And in fact, I should update this sometime to use tuples from C#7. Just pairs of values. What do we think division will do? Okay, we've got a few different examples here. Let's look one at a time. So let's start off with, we have some employees. This is our simple model using anonymous types. Everyone has a name and which department they're in. Let's divide by this lambda expression. What do we think this should do? Grouping, yes, thank you. So it's just going to group by department. So we should end up with accounting that's got Dave in, sales that's got Bill and Betty, finance that's got Holly and Edward, HR that's got Fred, and engineering that's got Diane and Tom. Okay, I'll run into it in a minute when we've looked at all the rest. In fact, yeah, I kind of gave it away by having this for each grouping in there as well. What about if we divide by an integer? So instead of having our employees here, we'll take to be or not to be, that is the question, etc. So we're splitting that by space and then converting it into our operator enumerable. What should that do? Split it into 5 parts. We could certainly do that. I think this instead splits it into groups of 5. And then that obviously means that when you use the remainder operator, we get whatever's left over. So we should have, it will be to be or not to, be that is the question, whether it is nobler in there, etc., and then our final group won't have 5 items in, so we'll leave that out, and then only show that when we find the remainder. So let's just check that. Division. Yep, so we're ending, the grouping is as I described. Ignore the fact that we've got these double commas, that's just because they're in the source text. And then at the end we've got by opposing in them, which just has 4 items in and wasn't in this grouping of 5. So this all feels kind of useful. If we look at operator enumerable, just for some of these, most of the implementations are very simple. So let's find the division that we've just done. So we've divided by, I'm sure I just asked for the right thing, and yeah, if we take a func dynamic to dynamic, because who knows what types are going to be involved here, then all we need to do is call the regular link group by. The batch part is, we've got to actually write that out ourselves, and then the remainder, I suspect, is effectively batching and throwing away. Yep, it's just clearing the list after it's reached the end of each batch, and then we can just return a new one of that. Okay, are there any particular operators? There's one more operator that I want to show. Is there any that you would like to see? We can come back to this, but I'm conscious of time. Nope, okay, let me show you some unary operators then. So, just as a reminder, unary are the operators that only have one operand, so they're minus and plus, basically. So I asked on Twitter, when I first wrote this presentation, what the negative value of a sequence should be, and I got some interesting answers. So someone suggested it should be the reversal. So the opposite of 3141592 is 2951413. Someone else said it should be the negative value, so minus 3141, minus 3, minus 4, minus 3, minus 1, minus 4, minus 1, minus 5, minus 9, minus 2. Or that it should be a strange popping thing, that each time you call the minus operator, you get back one element of the sequence, and it mutates the sequence to remove it. This is truly, truly horrible and evil. It's sort of subtracting one element from the sequence and returning it. Never ever mutate things in operators. Well, except. We'll see. So that's the negative operator, but you may have already guessed what's happening here. There's also the unary plus operator. Now, I've dedicated this operator to Eric Lippert, who has commented before that it's a useless operator. What on earth is the point of a unary plus operator? It's always going to return the same thing. Okay, it's only there for symmetry. It's there so that we can write, int x equals minus 5, int y equals plus 5. It's nice to be able to do that. It would be a shame if you had to just use 5. But it's kind of pointless. Well, I submit it's not pointless because it allows you to do things like this. So our plus operator sort of changes the mode of our sequence. We have these 3 possible implementations for the negative, the unary minus operator, and our operator enumerable retains, as well as the sequence that it's representing, it retains an enum value, which is what kind of mode, what should I do if you call the unary minus operator on me? And when you do plus sequence, it just returns a new sequence that has the same sequence of values, but it sort of goes round all the values within the enum, so it goes on to the next one. So by default, minus sequence will reverse the operation. But if we call plus sequence, then that returns something that will instead, when you call minus, negate everything. And of course you can do both of them. So minus plus minus sequence will return minus 2, minus 9, minus 5, minus 1, minus 4, minus 1, minus 3. And if you call plus twice, of course you can't call plus plus sequence, that's entirely different. But if you call plus plus sequence, then we can get 3 and then 1 and then 4, and then after popping we'll see 1592. And because there are only the 3 modes, if you call plus 3 times, you get back to the original version. So this minus plus 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 sequence should give us the same as this reversed. So let's just run this unary operators. So as I said, we started off with just digits from pi. We can reverse them, we can negate them, we can reverse and negate. We can pop from different bits, and that mutates the sequence, leaving 1592. And if we did plus plus plus, and then the unary minus of that, we get back to the reversal. So Eric is clearly wrong. Unary operator plus is a great thing that can be used to great effect and highly readable. I think it's really nicely obvious what that will do, I think. Okay. If we have any time left at the end, which I'm pretty sure we won't, I'll come back to link to operators because it's lots of fun. What's odds and ends? Let's go for where as enumerable. Is Ted here? Ted Neward? Nope. Okay, well, we'll do this in honor of him anyway. So this was actually an answer to a Stack Overflow question in the end. I hope most of you are familiar enough with LINQ that this is not too strange. LINQ to SQL or Entity Framework returns iQueryable of T. And you can do stuff with that, so if you do where and select and things, that ends up constructing SQL that can be executed later on. But suppose you want to do a select that does some formatting using some code that you've got on your system. Then your select statement needs to be, you need to be executing that locally. So if you do, db.users.select user goes to some local processing thing, that's going to fail at execution time. Yeah? So that is one of the reasons for using as enumerable, because as enumerable sort of transfers from being an iQueryable of T to an iEnumerable of T. That's all it does. It's the most trivial method that you've ever seen. So it's implemented like this. I can't remember whether it's in queryable or enumerable offhand, but it's something equivalent to iEnumerable of T as enumerable T, this iQueryable of T, source. It might do some validation, I don't know, and then it just returns source. It does nothing. It is effectively just casting the result to iEnumerable of T. And then if you use select, you'll be calling enumerable.select instead of queryable.select. So at execution time, all the right things happen. So we have as enumerable as an extension method, and that's great. But suppose you're a fan of query extensions, query expressions rather. So you like writing from such and such, where some condition, select something. And your where wants to be done at the database, because you want to filter at the database, but your select wants to be done locally. That's fine if you use method syntax, but it's a pain otherwise, because you can't put the dot as enumerable within the query expression. Or can you? Just like awaiters, query expressions are entirely pattern-based. All the compiler does is convert this source code into something like source.where x goes to x dot starts with foo, and then in this case where x goes to query hacks dot transfer to client dot where x goes to x dot get hash code, etc. So it's just doing that conversion and then compiling it as if it were C# without query expressions. Now that's interesting, because although select is nice and general, where is quite specific. The where method that link provides always takes a func from t to bool, or an expression of func of t to bool. Which means if you write your own extension method, which takes a func of t to some other type, then overload resolution is fine, because if query hacks.transfer to client returns something other than bool, then the two methods are fine. This will definitely go to the normal link method, and this will call our new method. So all we need is the query hacks code, which has a hack token. That's just a public nested class here, so that you don't accidentally end up using this. You're not going to write one of these. You can't construct your own one of them. And the instance is internal. So that allows us to transfer to the client and call as enumerable. Let's do a TED token instead. In parallel, that's called TED token dot instance, and now we just need a TED token. Yes, search and replace would have been faster. Okay, and now we need a way of just saying where with a TED token, and we'll make this source dot as parallel. And now if you want to write a query expression and do half of it in series and then break into parallel, we can just do query hacks dot in parallel. And suddenly we have a parallel query. And we can still keep using our query expressions here. Parallel.where, I think. And in fact, I should change the return type, because as parallel returns a parallel query of t. And I think its where method is in, it's not going to tell me where it is. Oh well. So you no longer need to worry about coming out of query extensions, expressions. You can just call in parallel and you're away. And you could then do where query hacks dot transfer to client instead, and that will call as enumerable, and it's all good. I would need something for parallel query of t for that to work, but it's nice and easy to do. Cool. I won't show the sneaky operator because that's no longer compiles. One more thing. Right. Performance. This is a fun one. This is useful, genuinely useful. I use it in production code, but use it with care, with a great deal of care. So I came up with this after writing some NodeTime code, and NodeTime has some relatively large structs. They're sort of 40 bytes in size. And I'm very performance sensitive in NodeTime because I don't know how my clients will use it. They may be writing performance sensitive code. The last thing I want to do is say, here, have this great .NET date and time library. By the way, it's slow as molasses. Yes, it will tell you what today's date is, but it will only tell you tomorrow. That's no good. And I found that there were a few places that were being relatively slow. Now, NodeTime is full of immutable structs, so They're structs that declare other structs as fields. And obviously, I wanted to make those read-only structs, read-only fields. Let's see why I've decided not to in the end. So if I run this, let's have a look at the code first. So we have an int256, and all it consists of is 4 longs. Okay, so that's just 32 bytes. I haven't implemented any of the numeric things. It's just a large struct. Now suppose I have a field called value, and then a property called total value, and that's just going to sum the 4 longs within the struct. Okay? So far this should at least not be confusing. You may be wondering why I'm doing it, but the code itself is not confusing. And then we do a little bit of micro benchmarking. We're just going to call total value once, and then call it a billion times and see how long that takes. So I need to make sure let's run this in release mode. So if this is anything like when I ran this in the airport a couple of days ago, it should take about 15 seconds. So long as I can keep talking absolute nonsense for about 15 seconds, and I've been known to talk absolute nonsense for whole hours at a time. There we go, 14 seconds. Okay, so a billion iterations, 14 seconds. That's not too bad. But it's slower than I'd like it to be. And in particular, this kind of thing ended up making Noda time slower than system.datetime, and that's never acceptable to me. So we can do slightly better if we say var copy equals value. And then we can do copy.bits0, copy. Let's run this. And this time it takes, do you know, I would have expected it to finish by now. I was expecting about 8 seconds. 11 seconds. You know, obviously, I have run this several times in the past to get a rather more scientific average than this, but it's a bit faster. Anyone have any ideas why it'll be a bit faster? Shout louder. Okay, if I understand the comment, it's sort of the JIT compiler can change the order of execution a bit, and that's sort of nearly right, but not quite. Local variables are just, you think local variables are just faster, we're not having to go to memory several times. Well, I'd expect it to be cached. Let me show you how we can get faster without using a local variable at all. I must C#6ify all of this code. In fact, no, I won't do that because it's much easier to put a local variable in here as it is. If I just make this not read-only, now I won't have to waffle for very long at all. Yep, it's done. What on earth is going on here? Surely a read-only variable, you know, thinking about JIT optimizations, you would expect a read-only variable to be simpler for the compiler. For the JIT compiler. You know, I can rely on it not changing, I'll do all kinds of cunning stuff. Well, not really. Because the C# language specification says, if you call a member function, so a property or an indexer or a method, on a struct, well, we don't want that to change things. We don't want that to change the value of the field if it's a read-only field. It's possible that this bit 0 could be implemented by saying bits 1 equals 10, return bits 0. It isn't, and you know, bits 1 is a read-only field, but the compiler doesn't know that. So when value is read-only, this code is equivalent to Local 0 equals value. Local 1 equals value. Local 2 equals value. Local 3 equals value. Return local 0 dot bit 0 plus local 1 dot bit 0, etc. In fact, the execution order would be copy value, call bits 0, copy value, call bits 1, copy value, call bits 2, copy value, call bits 3. And when you're copying 32 bytes, each of those times, that ends up being painful. When it's just the field directly without read-only, now the compiler says, do you know what? You've said it's not read-only, so if you call something that mutates a struct, sucks to be you. That's fine. Or in fact, not sucks to be you. Maybe you want it to do that because maybe you're using a tuple, a C#7 tuple, and those are mutable, and yeah, if you want to mutate stuff, then that's fine. So I see we're out of time. This is one of the downsides of doing this particular talk, which is one of my favorite talks to do because it's got so much horrible code. So this is one example that I have used in NodeTime. I explicitly have an attribute saying not read-only for performance reasons, and then I have a unit test that makes sure that those fields are definitely not read-only and they're structs, and that everything within those structs is pure. And I think at one point I wrote a Roslyn analyzer to make sure that I didn't have any setters for them within the rest of the code. But basically, you need to be careful. But this is effectively a quirk of the language. And for those of you who were at the Q&A yesterday, and we were talking about what the next language would look like, if things were immutable by default, then some of these quirks, I suspect, would go away, because you could tell, hey, this struct is pure. There's nothing that will mutate this, therefore it's fine for a read-only value. I'll just go straight to the field. I will let you go and get coffee and more breakfast and things. Maciek asked me to remind you that there are session evaluation things. If you log into your DeveloperDays registration console thing, then please go fill in the speaker evaluation forms. Obviously, be particularly nice to me. And there is a raffle later on that the more you evaluate, please only evaluate the sessions you've actually been to. But then, the more you evaluate, the more logical tickets you'll get in the raffle. That was Abusing C#. Thank you very much.